Hello world. In today's video, we are gonna go through one more problem for Newton's third law of motion, and then we are gonna get started with the universal gravitational law. Okay, so feel free to pause this video and try out this question for yourself. It says two crates M1 and M2 touch one another and are pushed over the floor of a storeroom. So what we're being told is there's a push there. The push over there is a force. So if we look at the diagram, M1 is the one which is being pushed, meaning a force is applied on M1. Because M1 and M2 they are in contact, if M1 is being pushed, then M1 is going to push on M2. In which direction will M1 push M2? It will push M2 in that direction. So we have a force that M1 applies on M2. Okay, so we are having two objects here. I'm going to call this A. I'm going to call this B. What we are saying is object A, which is M1, is applying a force on B, which is M2. And according to Newton's third law of motion, it says if A exerts a force on B, then B will simultaneously exert a force of equal magnitude in the opposite direction. So from Newton's third law of motion, it tells us that we have a force that M2 applies on M1. What is the direction of the force opposite to that one applied by M1? So we have M2 on M1. Okay, let us look at these forces. So this one, we are saying this force acts on M2. It means when we draw a free body diagram, we show it on M2. And then this one is acting on M1. That means it's going to appear on the free body diagram of M1. Because when we draw a free body diagram, we show forces acting on that particular object. Okay. And then it says a horizontal force of 200 Newton is exerted to the 80 kilogram crate, which is M1. All frictional forces can be ignored. So what this means is we do not have any frictional forces. Okay, so the first question says draw a free body diagram showing all the forces acting on each crate. I'm gonna start with M1. If we look at M1, it's on a surface. So parallel to the surface, we have the, oh, no wonder. Parallel to the surface, we have the x-axis. Perpendicular to the surface, we have y-axis. Where they meet, you place your object. Okay, now we can get started with the forces. Always vertically down, we have the weight. And we said we are having a force on this M1. This is the force exerted by M2 on M1. We also have the normal force. Doesn't look that nice. So we have our normal perpendicular to the surface. And finally, we have that force applied, which was called F. And then we get to M2, the same thing, because it's on a surface parallel to the surface, we have the x-axis. Perpendicular to the surface, we have the y-axis. I'm going to place the object there, always vertically down. We have the weight. And then we are having that force, the force that M1 exerts on M2. And lastly, we have the normal force. And that is our free body diagram. Okay. So let us see from this free body diagram. F is given. We were told that is 2000 Newton. This we can calculate at any moment. I hope you still remember. That will be 80 multiplied by 9,8. We can calculate the normal. So the force that M2 exerts on M1, that is the one that we do not know. If you go back to this free body diagram, this is equals to mg. We have the mass and the gravitational acceleration we can calculate it. We can even calculate the normal using some of the forces along the y direction. So once more, even on this free body diagram, we do not know the force that M1 exerts on M2. But what we know from Newton's third law of motion is that Okay, I think I need to reduce the size of this rubber. Rubber? Okay, much better. Okay, what we know from Newton's third law of motion is that the force that M1 exerts on M2 has the same magnitude as the force that M2 exerts on M1. Okay. Remember, before we even get to the second question, remember what I said in the previous lesson, that when you have two bodies, expect to generate two equations and solve for some simultaneous. Okay, so the second question says calculate the magnitude of the force. So we are looking for a force there. The formula that can already come to mind when we are asked to calculate a force, that will be F net is equals to MA. Because we have two bodies, we are going to write Newton's second law for each body. I'm going to start with M2. For M2, along the horizontal direction, we only have Fm1 on M2. I'm going to take right as positive. So we have Fm1 on M2 is equals to the mass there was given to us as 120. The acceleration is unknown. So we were told that these two crates were pushed over the floor of a storeroom. They never said the blocks were stationary, and there's no way that they can be stationary when a force F is applied, because there are no forces which are opposing motion. So they are not at rest. There's nothing about constant velocity here. So we cannot assume acceleration is zero. So you can never assume that. So I'm just going to leave the acceleration as it is. That will be my equation number one. So for the second one, I'm going to write Newton's second law using M2. If I use M2, I have, from the free body diagram, F in the positive direction minus Fm2 on M1 equals to the mass, which is 80, multiplied by the acceleration. This is my equation number two. So what I've said up there is, number one, I've said that these two forces, they have the same magnitude, meaning wherever I see Fm1 on M2, I can actually put Fm2 on M1 because they're same in magnitude. But what I know from the above statement is that this force is equals to 120 multiplied by the acceleration. Okay, so what I'm going to do is I'm going to do this slowly. So I'm going to sub 1 into 2. Okay, so what do I mean by substituting 1 into equation 2? What I mean is, where I see this force, I'm going to place that one because they are equal. So that will be minus F M1 on M2 equals to 80A. But wait, I know what this force is equals to. It's equals to 120A. So I'm going to write this as, remember F is 2000 minus 120A equals to 80A. Then we can group like terms. We're going to have 200A equals to 2000. How did I get that? I just transpose this to the other side. So make A subject of the formula, divide both sides by 200. You're going to get 10 meters per square second. Because it's positive, it means that the system is accelerating towards the right. But we were not looking for the acceleration. We were looking for the force that M1 applies to M2, which is that force over here. So I can back substitute into any one of these equations. I'm going to back substitute into that one. So it means that the force that M1 applies on M2 will be equal to 120, but now I know the acceleration, it is 10. So what that tells me is that force will be equal to 1,200 Newton. So we were only asked to calculate the size, and that is this size over there. Okay, that's it from me on Newton's third law of motion. Probably I'll just do another video on revision. But today's business is all about the universal gravitational law. So it's really about to get interesting. So the universal gravitational law, this is Newton's universal gravitational law. This law, according to the examination guidelines, states that each body in the universe attracts every other body. So each body, let me grab a highlighter. Each body attracts every other body. So if you have two objects and they are attracting each other, what it means to attract, it means they are pulling each other. And when we talk about a pull, remember a pull is a force. So what this part means is each body in the universe applies a force on every other body. Okay, so attracts every other body with a force. So we are talking about a force here which is attractive. So this force that they're talking about is an attractive force. I just want to go back to the name of the law. We are saying the law is the universal gravitational law. Gravitational comes from gravitation. When we talk about gravitation, it actually means attraction. So this means attraction. Gravitation means attraction. So when we talk about gravitational force, we are just simply talking about a force of attraction. So this attractive force that we are busy talking about here is the one that is referred to as the gravitational force, meaning force of attraction. So far the statement is telling us that each body in the universe applies a force of attraction on every other particle in the universe. Okay. So the other part, we're being told that with a force that is directly proportional to the product of their masses. Okay, so we are having two bodies over here. Let us say we are having body 1 and body 2. These two bodies, they have masses m1 and m2. So from what we have just read, we are being told that these two bodies, they attract each other. And this force of attraction, which is also called the gravitational force, I'm gonna represent it with F. But to distinguish it from all the other forces, we normally write it as Fg, even though on the data sheet they just write capital letter F. So this gravitational force is directly proportional to the product. When we talk about product in maths, that it has to do with multiplication. Multiplication of what? Of their masses. So this is the product, the multiplication of M1 and M2. And this statement over here is very powerful because it tells us the type of relationship that exists between the gravitational force and the product of the masses. And it also gives us a hint that if we were to draw a graph of Fg versus the product of the masses, what kind of a graph are we going to have? So if these two are directly proportional, it means when we draw the graph of Fg versus the product of the masses, then we are going to get a straight line graph which passes through the origin. So that's what that part tells us. And in simple terms, again, we can also say when the product of the masses increases, then the gravitational force also increases. And the last part says, and inversely proportional to the square of the distance between their centers. So they're talking about the square of the distance. Okay, how do we write the square of the distance? That is distance squared. Okay, so we're being told that uh, each body in the universe attracts every other body with a force that is directly proportional to the product of their masses, which is this part, and inversely proportional to the square of the distance between their centers. We are told that the same gravitational force, Fg, is inversely proportional to the square of the distance. And they are quite specific about the distance, that this distance, if I were to represent it on the diagram, that is the distance between their centers, the distance between the center of M1 and M2. That's the one that we call R. So if we say that Fg is inversely proportional to the square of the distance, it's telling us important information. It tells us that if we draw a graph of, let me write it here. If I draw a graph of Fg versus r squared, then I am going to get a hyperbolic function, Fg over r squared. And then we are going to prove this at a later stage. Okay, remember that there are two ways of interpreting this. You can either say Fg is inversely, the spelling disappeared there, is inversely proportional to r squared, or you can interpret it as follows, or the interpretation could be Fg is directly proportional to 1 over r squared. Fg is directly proportional to the reciprocal of the square of the distance between them. Using that statement of direct proportionality, it tells me that if I draw a graph of Fg versus 1 over r squared, then I'm going to get a straight line graph which passes through the origin. Remember, when you draw your graphs, you need to include units there in bracket. Okay, so we're talking about a force here, all forces measured in units of Newton, r squared, that is meter squared. That one, it will be 1 over meter squared. But if you want to write it with a negative exponent, you can say that this is m to the power of minus 2. And then over here, if I include the units, those will be kg multiplied by kg. That will be kg squared. And then this one is still units of Newton. What I want us to take from this is the graphs, number 1. Number 2, what I want us to take from this is that this gravitational force that we are being told is directly proportional to the product of the mass and inversely proportional to the square of the distance. From that statement, we can conclude that this force Fg depends on the product of the masses, and it also depends on the distance between the centers of these objects. So if we were to conduct an experiment where we want to know the relationship between the gravitational force and the product of the masses, then we need to understand that the dependent variable is our gravitational force. But what I'm going to do right now is I want to combine these relationships together. Okay, so the first relationship from the statement was F. I'm just going to write F, but we're talking about gravitational force here. Is directly proportional to product of M1 and M2. The other one is force directly proportional to the reciprocal of the square of the distance. If I combine those two statements together, I'm going to have something like F being directly proportional to the product of the masses and inversely proportional to the square of the distance. From this relationship, if I want to turn this relationship into a mathematical equation, then every time I replace the proportionality sign with an equal sign, I need to introduce a constant, which we call the proportionality constant. That is a tongue twister. My apologies. The proportionality constant for this is capital letter G, and then we still have M1, M2 divided by R squared, and then there's the F on the other side. This is our equation, and this equation we are going to be using it to calculate the gravitational force or any other variable that appears on it except G. G is a constant. It's always given on the data sheet. So G is called the gravitational constant. So it is a constant, does not change. And the value of G is 6,67 times 10 to the power negative 11 Newton kilograms to the power negative 2 meters squared. And we have said M1 is mass of M1 in units of kilograms. And when we talk about M2, this is mass of object number 2. That's what I meant to say up there. And when we talk about R is the most important variable over here. R is the distance between the center of M1 and M2. And then F, that is the gravitational force. And what we can do is we can actually plot these graphs using the equation as I have explained in the previous video. So that is exactly what I'm going to do. So I'm going to explain how to plot the same graphs using this formula that we have just seen right now. We are saying we have F is equals to G M1 M2 over R squared. With the first one, I wanted a graph of F versus the product of the masses. So what I intend to plot along the Y, remember this is Y versus X, I replace it with X on the formula. So I plotted force on the Y-axis, so I'm going to replace it with Y. And then on the X-axis, I have plotted M1 multiplied by M2. So that whole product, I'm going to replace it with X. And then I am left with G over R squared. Everything that remains, I need to represent it with a constant. I'm gonna choose my constant to be A. So let A be a placeholder for G over R squared. So it means I have Y equals to AX. If you look at this, the highest degree is 1. So it means that this is a linear function. And because there's no y-intercept there, it means this linear function passes through the origin. I want us to talk about A a little bit. A is G over R squared. This is positive, and I just gave you the value. And in the denominator, we have R squared. Anything squared will always give you a positive answer. So it means that A is always positive. Hence, we are getting an increasing function. But the question now is, what does the gradient of the graph represent? every time when I see a straight line graph, I always want to know what the gradient represents or what the y-intercept represents. So if we look at the gradient of this graph, how do we get the gradient? From the equation, that is the coefficient of x. What is the coefficient of x? It's a. So the gradient of this graph is a. But what does a represent? Remember that a was a placeholder for g over r squared. So what it means is the gradient of this graph is equals to g over r squared. So this is the graph we would have obtained if we wanted to investigate the relationship between gravitational force and the product of the masses. We just wanted to know how the product of the masses influence the gravitational force. Okay, let us try the other one. I am seeing another straight line graph there. Perhaps we can try to figure out what the gradient represents. I'm going to go back to my equation. F equals to G m1 m2 over r squared. What have we plotted along the x-axis? We have plotted 1 over r squared. So I'm going to rewrite this formula as G m1 m2 multiplied by 1 over r squared, so that I can make my replacement. So f will be replaced with y because I plotted it on the y-axis. This is equals to that whole part multiplied by this whole thing. I'm going to replace it with x. And whatever remains must be a constant. I'm going to replace it with a constant. I'm going to call it b. B represents g multiplied by m1 multiplied by m2. So that is b. What kind of a function? A linear function. What does the gradient of this linear function represent? It's b. So the gradient of this graph is b. What does b represent? B represents g multiplied by m1 multiplied by m2. And I need you to understand that the gradient of a straight line graph, is a constant. So being a constant, it means that g must be a constant. Is g a constant? The answer is yes. This product must also be a constant. We need to ensure that we keep the product of the masses a constant so that it does not interfere with this investigation to figure out the relationship between gravitational force and the distance. So if we were to carry out an investigation, because we need to keep m1 m2 the product a constant, it means this will be our controlled variable. Remember what a controlled variable is. A controlled variable is a variable that is kept a constant. Okay, so let us just look at an investigation there. It says investigating the relationship between force and the product of the masses. In any investigation, the most important thing would be the variables, yes. Also the investigative question, the aim, the hypothesis. So let us just take it one step at a time. For you to be able to write down the aim, the hypothesis, investigative question, you need to know what your variables are. So over here, we want to investigate the relationship between the force and the product of the masses. Which one is the independent variable? This is the one that we are going to be changing because we want the relationship between these two things. One, we have to change it, and then the other one, we need to measure it. The one that we measure, that will be our dependent variable. And remember I said that force depends on the product of the masses as well as R. So for this investigation, we have force as FG. We have the force as our dependent variable. Which one will be the independent? It will be the product of M1 and M2. So we want to know what the relationship is between these two guys. So what we need to do is we need to change one of them. Which one can we change? It's the product of the masses. And the other one, as mentioned, that is always a dependent in this investigation. And then it also says write down the control variable. This is the variable that we keep constant, and this variable is a physical quantity. I want us to go back to the equation and see what we need to keep constant. We have Fg equals to G m1 m2 over r squared. So the relationship exists between 1 and 2. Everything else must be constant. From the equation, G is not something that we can keep a constant. G is already a constant. Question is, what do we then need to keep constant? Because this guy can vary, we need to make sure that the distance between the centers of M1 and M2 is kept the same. We need to make sure that it does not change. So it will be the distance between the center of M1 and M2. Please note that I'm writing R and not R squared. The physical quantity, the measurable quantity here is the distance between the centers of M1 and M2. That is the physical quantity. And when we write here with the variables, we are writing the physical quantities. I hope that is clear. Okay. And I also mentioned that we need to be able to write down the aim. What is the aim? The aim is the goal. It's what we are trying to accomplish. What are we trying to do here? We are trying to investigate the relationship between two variables. So your aim always takes the form to investigate the relationship between the independent and dependent variable. Okay, so this is the skeleton. So for any investigation, you need to go back there and replace the and put in the appropriate independent and the appropriate dependent. So this investigation, we said that the independent is the product of the masses. So you go and put it there. The product of the masses of the bodies, just to be specific, and the dependent, which is the gravitational force. Okay, so your aim is a statement to investigate the relationship between the product of the masses and the gravitational force. The next thing will be the hypothesis. The hypothesis is a guess, it's a prediction, a scientific prediction. So before you carry out the investigation, you predict the relationship between F and the product of the masses. Because we have seen this equation up here, the prediction might be F is directly proportional to the product of the masses. By the way, the prediction does not necessarily need to be true. So with the hypothesis, you predict the outcome. Hypothesis, you predict the relationship between independent and dependent variable. What is important is that in the prediction, the independent variable must be there, the dependent must be there. So I already made the prediction. The prediction is that the force is directly proportional to the product of the masses. And the other one is the investigative question. What is important is that this is a question. It must have those words which indicate that you are asking a question. What? How? And most importantly, there must be a question mark. So the investigative question always takes the form, what is the relationship between the independent and dependent variable? That is the skeleton. So our investigative question might be, what is the relationship between the product of the masses and the gravitational force? Or someone might have phrased it with how. How does the product of the masses affect the gravitational force? Have the question mark there at the end. Now, when you write a conclusion is true. It's what you obtain from the investigation. When you write this, I need you to be careful with it. I want you to follow cause and effect. For example, if you say, if you drink poison, you will die. There's the cause, drinking poison, effect, death. But the opposite of the statement is not necessarily true. If you die, you drink poison. It doesn't always mean that if someone dies, they've drank poison. Not always true. So write it with cause and effect. For example, let us say you wanted to write it in terms of increase and decrease. You can say, as the product of M1 and M2 increases, then F also increases. And it is not true to say when F increases, the product of the masses also increases, because you make it sound as if the product of the masses depends on the force. So also always follow cause and effect, because there are cases where we need to write the conclusion in the form, when this increases, then the other one increases. What is important is, if you want to phrase the conclusion this way, then it takes the form, as the independent increases, you'll choose the correct word here, increases or decreases, then the dependent increases or it decreases, whichever one. So in our case, we could say, as the independent, the product of M1 and M2 increases, then the dependent, which is F, increases. Or if you can see how the graph looks like from the obtained data, then you can immediately say F is directly proportional to the product of M1 and M2. So I'm going to skip these ones because we have already discuss them. And in the next video, we're going to look at the factors which affect the gravitational force. Till we meet again, thank you.